Hello, welcome back to Cracking the Cryptic, and a puzzle with some arithmetical symbols in the grid today by Valdronius, a new name to the channel. Welcome Valdronius, and I'm going to have a look at this in a minute. I am going to tell you there may still just be time to get your entry in for the Spider-Man Sudoku, which is our hunt for the month and is available on Patreon, where we also have some tough crosswords. Simon has a go at Oscar Johansson's this month, and later in the month it has been postponed. My monthly club special will be coming, and there are also gridogram and connections videos on Patreon. It's great fun, loads of good stuff. We've also got apps which feature Domino, Sudoku, and classic Sudoku too, and the Worms, including Blobz's Worm. That's fabulous. We've got, what else have we got? We've got a bit of merch as well, so check that out too. All good fun. The links under the video will take you to all of that, as well as to this puzzle, Simple Arithmetic by Valdronius. I'm going to go through the rules in a moment. What I'm going to say first about the symbols is that we're not going to sit here and complain that they're quite big and black and will fill the cells and obscure some of the numbers we're using, because that's Valdronius' choice, and Valdronius is the creator of this puzzle and has worked very hard to give us a Sudoku we can solve, and it's up to them. Right, the rules are these. Normal Sudoku rules apply. 1 to 9 will go in every row, column, and 3 by 3 box. Any cell marked with a plus, minus, times star or divide slash is the sum, difference, product, or quotient respectively of the two orthogonal cells either vertically or horizontally beside. So this star is either the sum of those two cells, the product of those two cells, or the product of those two. And this plus must be the product of those two because it doesn't have a horizontal pair. All such cells have been marked except where a cell qualifies for 2 marks, and in this case only 1 mark is shown. Well, I'm the only 1 mark who's going to be trying this puzzle in front of you. I understand those rules. I hope you do. Let's get cracking. So, I think the cells within the center of the puzzle are harder to use than the ones on the perimeter. So I'm hoping to start with those because we know where the pairs are. So for this star, right, we can't use a 1 as a factor on one of the, so these 2 yellow cells must multiply together to give this star digit because it doesn't have a vertical one, obviously. Now we can't use a 1 there, or the other 2 digits, the yellow, the remaining yellow and the star, would be the same digit, and that would break Sudoku rules. So we must be multiplying 2 by either 3 or 4. Otherwise we're going to get out of Sudoku range. And 2 by 3 is 6, 2 by 4 is 8. So that's what we must be getting there. Now, this star is very similarly multiplying 2 by 3 or 2 by 4, because the same strictures apply to not using 1s for that one. However, we don't know whether it's those 2 cells being a 2 and a 3 or a 2 and a 4, or those 2. We do, however, know that the output, the result, the product is another 6 or 8. So we have a pair. And yeah, I don't know. Okay, one of these cells is going to be a 2. That's not very interesting information, is it? Yeah, it's definitely easier to... Right, let's look at the divide that's on the perimeter. So I think the same stuff applies. We can't use a 1 because that would make a digit repeat in this divide sum. So again, it's 2 times 4 is 8, or 2 times 3 is 6. But this time, well, the product, the quotient, the result of the division is 2, 3, or 4. That's harder. It's not as useful because the factor and the other divisor are, or the multiple and the divisor are selected from 2, 3, 4, 6, 8. So I know that one of these digits is a 2. I mean, I suppose I know that one of these yellow cells is a 2. But that doesn't really help much with this plus. Yeah, this is weird. It's difficult to get started, Valdronius. Well done. I thought this would be just, oh, we attack it and we find some things and we get going. It's not. It's quite hard to start. Okay. Is there something about even digits down here? These two cells are definitely even. So the only remaining even digits I have left that could be involved in this plus are 2 and 4. Right, the plus is not where I said that around this 6 or 8 there must be a 2 in one of those cells in this box. It's not there because that would then be the result of 1 plus 1, and that would put 2 1s in the same box and column. So the 2 in this box is in one of these 3 cells, acting to create this 6 or 8 product. That means that the only even digit available for this sum is a 4. Now, this is very significant, or it's a bit significant, because we need an even digit in this sum. We can't have 2 odds added together equaling odd. So there is a real parity issue here. We must have 4 in this group, and it's either odd plus odd equals 4, and we could work out how that would work, or it's odd plus 4 equals odd. But it means this digit is not 4. Now, it doesn't mean that this doesn't have 4 in its factors, because it could be 4 there and 2 here, giving 8. And then this would be 3, 6, 2. And that is possible. In fact, oh no, that is not possible, because if we had 4 there giving 8 and 2 here, we would need a 1, 3 pair there, so we could not have 3 here. So this is not the 4. The 4, unsurprisingly, is one of the addends here. We're adding it to something else and getting an odd total that is 5, 7, or 9. We're adding it to 1, 3, or 5 and getting 5, 7, or 9 there. This is where it's a little difficult to read the candidate numbers because of the thick black lines, but that's fine. Now we know that this is a product of 2 times 3 because it doesn't use the 4. And the 2 times 3 can't be that side, so it must be up and down. 2 and 3 there gives 6 here. This digit is now 8, so these have to be 2 and 4, and that one is 2, and this one is 4. That is a lovely beginning, actually. That's really neat. So we've got started now. Now, maybe we know more about this because we're not using 3 in it now. So 4 plus 1 equals 5. We're not going to get a 7 in the center. That's the point of that. We're either going to get 4 and 1 here or 4 and 5 here, adding up to 5 or 9 here, and 7's going to be in one of those cells. Now, this plus is the only one where we know in this bottom row where we've obviously, I'm going to mark off as orange when we've actually done a sign cell. This one we haven't done. 4 plus this equals this. We've only got one even number. Oh, look, we can actually place 4 in box, box 7. So, oh, well, that's good, because now that has revealed that this is not 4 plus 1 equals 5, because then we couldn't fill in this cell. There can't be another even number involved here, or we'd need 2 of them, and we've only got 6 available. So this is odd, and we've just discovered it's not 1. It's 3 or 5, and this sum is 7 or 9. I'm utterly scared to move on to something like this, because I'm just going to look at that 4 and go, oh, we have to add something here to get that. We don't necessarily, because this could be adding side-by-side digits. And I'm very scared of just botching which way round the sum is. But I am running out of actual information or anything I can do. There is clearly a 6 in one of these cells. Oh, so therefore there's a 6 in one of these cells. That's not as... Oh, 6 would... If it's in a minus, it's going to be surrounded by either 9, 3, 8, 2, or 7, 1 in one direction. Yeah, that isn't easy. If 6 was here, this plus would have to be taking the digits side by side. Because 4 and 6 equals 10, so that wouldn't be giving this sum. Oh, goodness, I don't know. Oh, okay. Right, there's this overlap here, isn't there? So one of these divided by the other gives that, but that or that, one of those is subtracted from the other to give this. I might have to work through all the possibilities. So, no, I mean, that's very interesting straight away. If I wanted to make this digit a 4, these would be 8 and 2 to give the right division. Now, if that was a 4 and this was an 8, this just doesn't make sense. You can't subtract 4 from something or something from 4 to give 8. So if that's a 4 and that's a 2, oh, bother, you could put a 6 here. Oh, I thought I'd ruled out 4. I haven't. If that's a 4, this is going to have to be 2, and this could be 6. Okay, well, that's possible. So it would go 8, 4, 2, 6 in that case. If this is 3, this has to be 2 or 6. If it's 2, that could be 1 or 5. If it's 6, this could be 8. I haven't ruled anything out. And if this is 2, I suspect there are lots of options. Not so many, but I think 8, 2, 4, 6 would still work. Yeah, I don't know. That is not what I'm meant to be doing next. That's horrific. I find this very difficult. Maybe I need to go to these divide signs, which must always be like this one. It doesn't matter whether they're going vertical or horizontal. They must have 2, 3, or 4 on the divide sign. And they must then be flanked in one direction or another. Oh, that one can't be 4. But it could be either, well, this sum, it doesn't have to be vertical, it could be horizontal. If it was vertical, these digits would be 6, 3, and 2. Oh, then what about this? Then we couldn't, that would be 9 with a 5 here, or 5 with a 1. I don't know. Oh, this puzzle's hard. It's going to be about using things that are next to each other, or something. Wow, I do not know. I do not know how this puzzle is meant to function at all, even though I've done some digits and got a start. Is it about parity again? I mean, is it? No, because I'm looking at this row and just assuming they're all horizontal horizontal maths, and that's just not necessarily right. Oh, there's the negative constraint. All such sums have been marked. Oh man, I didn't think about that yet. And that's terrifying. How am I meant to be using that? Surely not yet. Oh, this is going to be terrible if I have to think about stuff like the negative constraint throughout. I mean, this isn't ruled out on this sum, I don't think, at all. Gosh. I suppose, look, this can't be a 1. Oh, this can't be a 7, because that 3 would have a minus sign. Oh my word, this is going to get hard in a hurry. Right, this can't be 1, as I just said, both for that sum and for that sum, because there is a relation between them. So it's 5 or 9, and this is the only place for 1 in the box, and this digit on the plus becomes 5, and that digit becomes 9, and we've suddenly finished the box, and we've done that 5 sum. Oh, this is going to be... oh, I'm horrified by the puzzle now. Right, this plus, if it was a horizontal sum, we'd have a 9 here and a 2 here, or an 8 here and a 1 here. If it's a vertical sum, right, this digit has to be more than 7 or 4, whether it's horizontal or vertical. So it is 8 or 9. If it was 8, we've definitely got a 1 here, because 4, 8, 4 is not allowed. So if it's 8, we've got a 1 here. If it's a 9, we've either got a 2 here or a 5 here. Oh, this plus can't be going vertically because of that 9. So it's definitely adding those 2 cells to make it. Right. That's, I mean, this is interesting, but my goodness, it's still terrifying. This digit, for instance, can't be 9 because of that grouping, and nor can this. Oh, well, 9 can't go on a minus, actually. Well, those are really important facts suddenly. This can't be 9 because that would be a minus. This can't be 9 because that would be a minus. 9 can't go on a minus because it can never be one digit minus another. So by Sudoku suddenly, and that bit of rule, this digit is 9. And now this is... well, these 2 add up to 9 to make this minus work. And they're not 5, 4, and they're not 1, 8. They're either 3, 6 or 2, 7. Where, I don't know which is larger and which is smaller. Oh, the negative constraint. I mean, this is going to be a beast of a puzzle, isn't it? Well, of course it is. But it's interesting to note that 9 can't be on a minus, because there's quite a few places where that matters in this. Well, I don't know. Maybe I ran out of them quite quickly there. Okay, if this digit is a 9, that's a 5, this is 8, that's 1. Then this is 3 by Sudoku. And then these are 2, 6, and 7, and we can't make this minus work. So this is not a 9, this is a 7, that's a 3. We've done this cell. That's crazy, but now 9 is in one of these 3. But much more importantly, 5 and 6 are in this pair, and this digit must be in a sum with 5 and 6. So they now have to be 1, 5, 6. In which the middle digit is not 6. Oh, this is crazy. This is, I mean, that's really clever. Right. These cells now are part of a 289 triple. That 8 or 9 is either being completed by a 5 there or a 2 here. And it can't be 8, I don't believe anymore. So that's a 9. But I don't know whether this is a 2 or that's a 5. I can't tell that. Unless there's some way I can tell. Okay, this can't be a 5, because then this group of cells is either 5, 8, 3 and we'd have a plus here, or 5, 2, 3 and we'd have a minus here. The negative constraint is massive. I did not expect that. Look at this. This can't go 1, 8, 7 or 5, 2, 7. So it's either 1, 2 or 5, 8 here. Oh, that's crazy. Oh, this can't be 3, 2, 6 or 3, 2, 1. 3, 2, 6 would get a divide here, and 3, 2, 1 would get a minus. So that digit's 8. This is 2. This can't be 5 and is 1. This must be 6 by Sudoku now, and that's a 5. And now this is done either way. It's a plus either way, that crazy cell. Right, this has been done. Oh, I messed up. I messed up big time. I assumed this was a horizontal minus sign. Right. I noticed that I messed up at least. Let's go back. Yeah, I went back all this way, didn't I? In fact, that's how I decided this was 7. I said if this was 9, this is 3, this is 8. This must be 1 to complete the 8. 4, 9, 5, 8, 1 have gone. By Sudoku, that's a 3. And then I said this can't be 2, 6, 7 because I was assuming this was doing a horizontal sum. That is not available to me as a method. So I have to be much more careful. Okay, but these negative constraints, they're huge. This digit can't be a 6 because that would have a plus in it. So one of these is a 6. I mean, that's positive constraint is barely any use with these interior ones. It's such a difficult puzzle now. I realise that now. I'm getting it, Valdronius. Gradually, I'm getting it. But it's difficult. It's difficult to get it. Right. 5, 6, 7. I mean, this is hard. So I'm going to briefly think about this 7 problem again. If that was a 7, no, if that was a 9, this is 5, that's 8, this is 1. This is 3 by Sudoku. So we've got 8, 1, 3 in that hypothesis. And 9 here. 9, 5, 8, 1, 3. So these would be 2, 6, 7. That couldn't be a 2, 7 pair because 9, 2, 7 would create an equation. So this would have to be 6. It would be sitting between 2 and 7. But it would be sitting above a 1. And that would be 6. This would have to be 7. And that would then have to be getting its 7ness from a sum to the side. Oh, this is so complicated. I mean, I'm looking ahead a long way there, and it's just difficult. It's difficult to achieve it. Okay, this digit can't be 9, 8, or 7, but it's the sum of 2 cells. So it's 3, 4, 5, or 6. And these ones are low. They're from 1, 2, 3, 4, 5. On this side, must be 1, 4, or 5. On this side, 1, 2, 3, or 5. Now, this cannot be that times that, because it just can't be big enough. On these divides, we've got to have a 6 or an 8 on one side or the other. So that's on this side. This digit is... no. There's me assuming that this has a vertical sum. That's not known. Oh, gosh. That is not known. It's weird that I was able to predict the problem I was going to have with this puzzle, and then I've been constantly having that problem of looking at these interior signs and assuming I know which way they do the math. I just don't. Okay, let's come back here then. I mean, I've got nothing. There's a 6 in one of those cells. I've got to use this negative constraint incredibly hard. I really have got to. But I don't know what I can do with it. There's a 6 in one of those. There's a 4 in one of these. This trio uses either 6 or 4. This digit can't be the complement of 3, 4, 5, and 6 in a 9 sum. No, it could be. Oh, that's weird. Yes, that trio. Then we'd have the situation where only one mark is shown in that cell. So it can be. In fact, oh, wow. I hadn't allowed for that. Oh, I would quite like to... Yeah, that's strange. I would quite like to say that this digit can't be 6 or 8, because that would at least make one of these two 6 or 8, but this might be able to be 6. This would be a 2-3 pair if the sum went horizontally there. Sorry, if you understand how this works and you're getting wildly frustrated with me, well, there we go. But I have to get through it at my own pace, otherwise I just don't get through it. So there's no real apology available. Right, there's an 8 in one of these two cells. That's quite a big deal. That 8, wherever it is, has to be between 9 and 1. It can't be in this cell I'm in, because you can't put 9, 1 there or there. So the 8 is not there. This is the 8. Now, it's either going to put a 1 there, or a 1 here and a 9 there. So one of these two is a 1. That's what we learned there. This cell now can't be a 1. And this plus, which I have to be adding across, is going to require a 5 or a 6 sum, and 1 or 2 in this cell. This digit can't be 8 anymore by Sudoku. Now, there's a 1 in one of those cells to deal with this. Now, negative constraint. That's what I should be thinking about a bit. For this to be a 2, this has to go 4, 6, 2. That would be 3. I always think I know that means what this is, but I don't. 8 minus that is that. I know that 8 is the biggest number in this trio because 9's gone. So these two do add up to 8. In some means, by some means. don't know how. 8 on a minus sign. That's a powerful thing, isn't it? I mean, it just is. Right. Let's just keep going. We've got a 9 in one of these cells. It might have to be here if this was a 1. Okay, interestingly, if this was a 1, this digit couldn't be 4 because of this trio and no symbol there. So it would be 5. And this would then be 6. And this would be 1 over here. We'd have 1, 5, 6. This would be a 2, 7 pair. These would be 3 and 4. I don't know. It's not impossible, I think, but it is interesting. I'd know, no, I wouldn't know the order of 3 and 4 based on this not being a minus, because it's a plus. I would know the order of 3 and 4 based on these two adding up to 8, actually. Oh, well, that'll be quite interesting. Right, if this is 1, this has to be 5 by the negative constraint. Then we get a 6 here. We've got a 2, 7 pair over this side. This is 3 and this is 4. This is 5. This now can't be using the 5, so it must do a horizontal thing. And it must go 4, 2, 8. That feels like it's not impossible, but it would be quite powerful one way or the other, wouldn't it? Goodness me, this puzzle's going to do my head in badly. This digit is a minus thing. It can't be going up and down, because that would either be a 4, 4 pair or there'd be 3 there and 3 there. Is that right? Yeah, it is. It is. Yes. So this isn't going up and down. This is going side and side. So those two subtract one from the other to get that. I mean, this may not particularly help, but it's worth noting that we have got a relationship between those 3 digits. Oh my goodness, this is crazy hard. I did not expect this workout from this puzzle. It is insanely hard to understand how to do it. 9, 8. We've got an 8 in one of these cells. I mean, there is a whole bunch of negative constraint in this puzzle. Wow, it's incredible how much there is. I do want to get through. I do want to understand it. It's going to take ages. This is going to be a very long video. What are we, half an hour in already to the solve? Oh, goodness. Right. Can this be a 7? The answer is no. Because its surroundings would either have to be an 8-1 pair or a 2-9 pair, and that's not possible with them having gone. So this isn't 7, so the 7 in the box is in one of these 2 cells, which we know add up to 9, so now we know they're a 7-2 pair. And that gives us a 3, 6, 8 triple up here. 9, 8, 2, 7. 3 is now in one of these 2 cells by Sudoku. This is the subtraction of a 2 or a 7. Well, if that was a 2, clearly these 2 add up to that. But that can't be anything bigger than 6. So this would either be 2, 4, 6. It can't be 2, 1, 3 because that would break this cell, but it could be 2. Oh, it can't be 2, 3, 5 either because that would also break this cell. So this would have to be 2, 4, 6. And that breaks these because they both become 5. So I actually think this can't be a 2 now. Right, let's go through that again. This is definitely doing a horizontal sum. It's the minus of one of these light blues versus the other. If that was a 2, this is not the highest digit in the sum. This is. So those two add up to this. They can't be 2, 1, 3 or they break this. They can't be 2, 3, 5 or they break this. They must be 2, 4, 6. But that breaks this pair, which both become 5. They couldn't be 2, 5, 7, because if that was a 2, 7, 8, 9 would be ruled out of that cell. So this is not 2. This is 7. This is 2. 7 is now the highest digit. It's the highest digit in the box available for this sum. So these two add up to 7, and they don't use 2. So they're either 4, 3 or 1, 6. Okay. What's that taught us? If they were 4, 3. Oh, goodness me. I was going to say that would be 5, that would be 6. We'd have 3, 6, 9 here. No good. But it is good. It's fine. Because there'd be a plus there because there couldn't be a minus. Wow, and that's if it was 1, 6. This would be 4, 5. This digit would be a 3. That would definitely be a 5 at that point. Okay, what if it's 4, 3 here? Then we've got 5, 6, and that's a 1. So this is either 1 or 3. Right, let's have a little think about this minus sign. It's either created by an 8 there and a 7 here, which would not be contributing to this sum. Or it could be a 3 here and a 2 here, or a 6. If this was 6, that would be 5, 4, 1, 3. Right. In that case, we'd definitely have a 5 here, because 6, 3 can't leave a 3 or a 9 here. Okay, so if that's a 6, this is 5. If this is a 3, then this is a 1. And this might be a 7, but it might be a 2 here instead. Oh, ow. Right, this can't be a 3, 6 pair, because 3, 6, 9 would form a minus here. So one of those is 8, and that's not 8 at the top. I mean, this is absolute negative nonsense that I'm trying to do now, but there we go. If that was a 1, I was going to say this couldn't be a 7 or a 9, but this sum would be irrelevant because there is a minus in the middle cell. That is such a hard rule to get used to. Oh, if this was a 4, this would be a 1, and that would be a problem here because there'd have to be a plus here, so it's not a 4. It's simple when you see it. It's not simple till you do. Now, I filled in all those by Sudoku. I can even fill in that and this by the yellows being added up. Those two sums are both fully done. This 8 is done by 9, 1. That 1 is going to be done by either a 7 here or a 2 or a 4 here. That's quite a lot of optionality. This 2 can't be north-south. It must be east-west. This digit is a 6. And that one's done now. Right, well that was a bunch of progress. These remaining cells in the row, 1, 5, 8, 9. Now here's me immediately assuming, oh, we have to have an 8, 9, 1 group here, but this could be going north-south. 1, 2, 6, that can't be a 1 in the same box. This is a minus sign, so it can't be a 9. If it was an 8, it would have to be surrounded by 9, 1, either there or there. Neither of those are possible because of this, so that's a 5. And this digit, if that was an 8, oh yeah, it would be surrounded by 9, 1. Ah, right. Let's look at the 5. Oh, that could be 6, 1. Or 4, 9, 3. I mean, there's all sorts of possibilities for that 5. I just wanted to prove this was a 1 first. Oh, I could look at this now. That minus, look, it could go 3, 6, 9. Oh, I thought at least I could rule out the higher digits from here somehow. Two, 3, 6, 9. That's so possible. It almost, no, it's not. Okay, here's why that's not possible. For this to be a 6, this has to be, oh. Okay, I was going to rule 2. I am going to rule 2 out of this cell because this needs a 2 around it, or to be a 2. Because the sum that's acting either there or there to give this quotient needs a 2. It's either 2, 4, 8 or 2, 3, 6. And if that's a 2, none of these cells can be a 2, so that's not 2. This sum does need a 2, so the 2 is now in one of those cells. So this sum is using a 2. This sum that's giving a minus number here is using a 2. It could be 3, 2, 1. If this was 8 or 9, I think the only way you get 2 close to them, so it could be 2, 6, 8 or 3, 2, 1. We must use a 2 here for this calculation. So I think those are the only possibilities, 2, 6, 8 or 3, 2, 1. And I'm going to leave them as the only possibilities left. This is now a 1, 8 pair, and this digit is a 9. This 5 is now getting its sum from north, south. This is done whichever way round this 1, 8 turns out to go. I mean, this puzzle is mad, and I could be making logical errors occasionally. I just cannot legislate for that entirely. I'm doing my best. This is a 9, 8 pair by Sudoku, and 9 can never be on a minus sign. So that's an 8 and that's a 9, and that is indeed 9 minus 1. So it's been done. This now has to be 9 minus 4 to exist. These are a 3 and a 7. Yes, sure, I could put 3 here and it would be 7 minus 4. But if I put 7 here, oh no, I can't put 1 there. That would be the wrong way around. So I'm going to do that 3 and 7. And that's done. This is now done. 8 minus 7 gives the 1. These cells are 2, 5, 6. I've got to look out for the negative constraint in a moment. These are 3, 4, 7. That works very nicely for this as long as it's not 7, but it could be a north-south minus sign. Are these not tidied up yet? 5 is now in one of those two. Oh yes, this becomes a 3 thanks to that 5. That does tidy it up. We get a 7 here, we mark it as orange. That doesn't sort this out, but 9 is now in one of these two cells. If that was 8, we would need a 1 here. That's possible. Five is now definitely in one of these two. These are from 1, 2, 7, 8. I mean, we've got, okay, 2 has to be amongst them. Otherwise, this would be a plus or a minus in a sum of 1, 7, 8. So there is a 2 there. That means that one of these two is a 2. Okay, let's go through the possibilities here. If that's 8, this is 1. If that's 9, either this is 2 or that's 5 or both. Oh, 6 is looking at that cell, so that can't be a 6. This one couldn't be a 6 because of that trio, so we've placed 6 here. Now, that is not doing an up and down minus, so it's doing a left to right one. Let's mark that yellow. Get rid of these other colours that I've used. Right, that is doing a left to right sum. It's either got 7, 1 left, right, or 2, 8. This digit is 1 or 2, and this one is the high one, 7 or 8. That's now a 1, 2, 7, 8 quad, and this digit is 5, which remains in the row. Yes, it couldn't be 5, 6, 1 because the minus would be the wrong ruling. Right. This could be a 1 horizontally. It can't be a 2 in either direction. So I'm writing a 1 in there. And in fact, that has now been done. And this 6 is therefore needing a 7 here. And the 6 is therefore done. Now, this is not done yet, but I don't think it can be 8 anymore because that doesn't work north-south and would require a 1 east-west. So that's a 9, and it is done north-south. It doesn't really matter now whether it gets done east-west. But by Sudoku, we do find out what those digits are, and this 9 actually works both north-south and east-west. Wow. Okay, this is going good. Now, this is going well is what I mean. I'm very sorry for the poor grammar. 3, 4, 5 there. This minus, oh, I feel like it's an 8, 3, 5, but it could be north-south. This is a 5, 6, 9. Oh, soon I'm going to be able to come to things on the perimeter, which is marvellous. That's where I can do actual work. This minus must be a north-south one, so these add up in some way. I don't think that can be 3. Because you can't get a difference of 3 between any two digits either side of it. I don't think it can be 4 for the same reason. That's true. That's a 7. And it must be surrounded by a 1, 8 pair. So now we've found 2 here. And that's 8. And that's 1. And this is 8. Right, that 7's been done, north-south. And now this has been done whichever way around the 3, 4 works. That's fine. This digit is a minus, so this can't be 6 anymore. This is 2, this is 3, this is 6. And both of these perimeter values are done along the perimeter. That was my last perimeter set, so I hope it gets easier now. This digit can't be 3, and I don't think it will. This can't be 6. We've got 4, 5, 9 left in the column. This can't be 3 in the box anymore. That does, well, also, this is now part of a 2, 4, 8 sum. Either, oh, these digits are 1, 2, 7. Oh, look, we can just fill in a lot of these. 4, 5, a lot of triples anyway. 3, 6, 8 there. 2, 4, 5 here. 3, 6, 8 we've already had. 1, 7, 9 there. Now, no 2 in those cells. Now, oh, that was done ages ago. I should have made it orange. We've only got 4 sums left to create the rest of the Sudoku here. So, I don't know. Right, this one cannot be working horizontally because 3, 4 and 5, no two of them can add up to give the other. So this one must be working vertically with a 2 subtracted from, not 9, either 6 to give 4 or 5 to give 3. Now that's a 3, 4 pair and that's a 5, 6 pair, and everything else in the column is 1, 7 or 9. That can't be 9. The only place for 9 in the final column is at the bottom. 1, 7, 9, 3, 6. Ooh, this can't be involved in this sum. 1 is not allowed because it causes a repeat, and 7 and 9 are not involved. So this is a vertical sum of 2, 4, 8. A vertical, well, but when I use the word sum, I'm sorry, I think it's British. That can be a mathematical problem, an equation is probably what I should say. Anyway, that makes this a 5. This becomes 3. That's 4. This is 3. This is not 3. Oh, I don't like my pencil marking down here, and now I have to go back because I botched it. I botched it back here. No, I got, well, okay, let's just see when I did the pencil marking, because it's not a 3, 4, 5 triple at the bottom here. It's a 1, 3, 4 triple. I just misread the row there. 1, 3, 4. And I mean, that's going to make this very available for a horizontal version. Okay, I'm really sorry. Oh, I just thought I was cruising to a finish there. Now, that's 5, 6, 9. Let's get it right this time. Yeah, these mistakes do happen. Now, this, though, that can't be, it could still be 6. No, it can't. If that was 6, this would go 2, 6, 8, and that cell would be impossible. So that's a 2. And then that is the difference between 1 and 3. And now this must be a 6 to make this division work, and those are both done. I think a lot of this is going to be the same logic as I was trying to do. Oh, this has become a 4. That's a 7. This is not 6. We've got 5, 9 at top and bottom. That can't be a 3. And we can't put 6s in any of those cells. So this is in a 2, 4, 8 triple somewhere. We've taken 4 out of those, and this is actually done. Now, I worked on this being north-south. It certainly doesn't have to be, because it's done east-west. This is done. This is done east-west, whatever digit it is. That's an 8. That's just Sudoku. And it's done. Those aren't 2s. So now I don't have all these things going on up and down as I thought I did, and I have to do a bit of better work. That's not a 9. So we have got a 5, 6 pair in this column, a 9, 7. Right, for this to be part of a 2, 4, 8 sum going east-west, a 2, 4, 8 equation going east-west, that would be a 2, that would be a 4, and this would be impossible. So it's not. So this is part of a 2, 4, 8 equation going north-south. Can't be 2, 3, 6 because of the position of that. So these are 2, 4 and 8. That is a triple. And now 3, 4, 1, 3. This doesn't work east-west, so we've got to make it work north-south by putting a 6 in there. That gives me 5, 6 here. These are from 1, 5, 7, 9. And this is done north-south. This is done when we get 8, 2, 4 in here. It will be done north-south. Okay, this is good. That can't be a 4, or this would have a minus north-south. Got to still look for these. Oh, these negative constraints. That can't be a 9, or this would be a minus between 9 and 3. So that's a 5. That finishes the bottom 6 rows. You would think we were close to a finish, wouldn't you? You'd hope we were close to a finish. Right, I can put in my triples up here. Try and not get them wrong. 459 there. That makes this minus all too easy to fulfill. 368 there. Okay, this is a 245 triple. This is a 179 triple. I can take 5 out of there, 6 out of here, 3 out of there. Okay, so now this can't, oh no, that has got a sign in it, so I can't rule on that. I'm trying to compare sort of 3 cell pieces up here. But again, there's a sign there. Oh, I haven't coloured this in. There's a little minus sign hiding behind this 4. I can colour that one in. This one, though, is not working horizontally. So that is going to have to be either a 9 or a 1. That must be 1. Well, that might be quite helpful. We can take 1 out of a couple of cells, which are now a 7-9 pair. There's also a 6-8 pair in the row. That digit is 2. That gives me 4 and 8 up there. Now, that takes 4 out of a couple of cells, 8 out of 1 cell. There's a 3-6 pair in the row. Doesn't that do anything? Okay, let's go back to this 6-8 pair. That can't be 2 anymore. There's a 7-9 pair, so that can't be 9. Now, this can't be 9. It doesn't matter whether it's horizontal or vertical or running rings around a carousel. You can't put a 9 on a minus sign. So that's a 5. And that is going to do, I mean, the 5 is done immediately north-south, but that's fine. In fact, that's the last sign we had to fill in. So hopefully the rest of this works by classic Sudoku. Because if it doesn't, I really haven't got any more shots to fire. That's not a 7, right? No, I've got the negative constraint to fire. That is a big shot that I do have left to fire. That can't be 9, this can't be 7. Yeah, it doesn't work by classic Sudoku. We've got clear deadly patterns there and there. So we're going to use the negative constraint and say that this can't be a 3 between the 5 and the 2, or it would have a minus sign on. And that does one of the deadly patterns. And then this can't be a 1 between the 3 and the 2, or it would have a minus sign on. And if this is not the solution, I'm going to break down in tears right now. Let's see. Done in under an hour. Oh, nobody's done this one before. That's brilliant. What a puzzle. What an annoying backtrack I had to do late on there. That is so clever and so devious and so surprising. I think the rule set will be used again by someone. And I expect it'll be someone who can watermark it a bit better so we can see all our digits. That is a very clever puzzle. Well done, Valdronius. Great fun. Thank you for doing it. And thank you guys for watching me. It's such a pleasure to bring you these incredible constructions by geniuses every day. I'll see you again soon. Bye for now.